Good morning, dear students. My name is Ferhan Mazher, and today is 25th of September 2024, 21, sorry. And right now I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. And today we have set our hearts to solve an MCQ paper. And today we are solving May-June 2021 paper. This paper belongs from the zone 2, from the variant 2. The paper is about the MCQs, and we will be, it has 1 hour time limit, and it has 40 questions, and you have to attempt all of them. So let's start today's paper, and here we go. So the question number 1 is coming up on your screen. A student determines the circumference of a football. Which instrument gives a reading that is the circumference of the football? A caliper can give you the diameter. Micrometer can also give you the diameter only. Rule cannot be used in the case of a football directly. Directly it cannot be used. Tape can directly measure the circumference of the football, because you can wrap the tape around the football, and you can directly measure the circumference of the football. So I think that D is the right choice. So I think D is the right choice. So let's go to the next question. I have already solved it. Let me check my answers. So I have these answers with me. So let me take a look at that. So the question number 1, yeah, D is the right choice. Question number 2 is showing up on your screen, and here we go. It says a coin falls from the rest through the air and eventually reaches a constant speed. So this word is very important, and eventually reaches a constant speed, eventually. So before, the speed was not constant, but as the time passes by, it got to the constant speed. It achieved constant speed, which we call terminal velocity. So there is a resultant force acting on the coin due to the two forces P and Q shown in the diagram. What happens to the force P, and what happens to the resultant force before the coin reaches the constant speed? So you know that when this force Q is actually the weight of that coin, and that P is air resistance. So as this coin falls at the start, the P value is 0, and the weight is obviously equals to the weight. And during the fall, the Q do not change. The weight of the coin do not change. But the value of the P is because the P is air resistance. As the body falls, its speed increases, so the air resistance increases. So gradually the value of the P is increasing. As the value of the P is increasing, you know the resultant force, that is equals to Q minus P. Weight minus air resistance. So because the weight is constant, but the value of the P is gradually increasing. As the speed is increasing, the value of the P is increasing. So at the start, the resultant force will be maximum, and as the body will achieve speed, the P value will increase. So the value of the Q minus P will gradually decrease. So it means the value of the P is gradually increasing, and the resultant force, which is equals to Q minus P, that will gradually decrease. So the value of the P will be increasing, and the value of the resultant force will be decreasing. So I think C is the best choice. I think C is the best choice. So here we go. We are on the question number 3. The diagram shows the forces acting on 4 identical solid blocks. Each arrow represents a force of 20 Newton. Which blocks are in equilibrium? That block will be in equilibrium where the two forces are acting on the same body but in opposite direction, and they will not produce a turning effect. So for example, if you look at this, so these two forces both are 20 Newton, they are acting in the opposite direction, and their line of action is same, so they will cancel out each other. Here, the line of action is not the same, so they will rotate this body. So this is equilibrium, the P is in equilibrium, and this R here, the forces are in opposite direction, acting on the same body, and their line of action is same. So they will cancel out each other. So the R will be also in equilibrium, the forces will be balanced. Here, both the forces are acting in the same direction, so these forces they will not cancel out each other. So this is not in balance. Equilibrium, I mean. So P and the R, they are in equilibrium. So the question is, which blocks are in equilibrium? I think P and R. So I think question number 3, A looks the right choice. Yes, A is the right choice. A is the right choice for question number 3. So now we have that question number 4 coming up on your screen. A student lists 3 changes that affect the stopping distance of a car, increasing the braking force. Increasing the braking force means that you increase the braking force. That will not affect the stopping distance. Increasing the friction between the tires and the road, yes, that will affect the stopping distance. If you increase the friction between the tire and the road, actually decrease the stopping distance. So this second one is a factor which will affect the stopping distance. We are talking about the stopping distance, and increasing the speed of the car. Yes, increasing the speed of the car. If the speed of the car increases, the stopping distance also increases. So 2 and 3 are the 2 factors which will increase affect the stopping distance. Number 1 is not going to affect. The braking force is the force with which you applied the brakes. That will not affect the stopping distance. Okay, so which change or changes increase the stopping distance? So we are talking about which change or changes increase the stopping distance. So we are looking for that which will which will increase the stopping distance. 1 and 2. So if you increase the braking force, it will, I think, reduce the stopping distance. And number 2, increasing the friction between the tires and the roads, it will also decrease the stopping distance. So A cannot be the choice. The 1 and the 3, increasing the braking force might decrease the stopping distance. So, but we are looking for that factor which will increase the stopping distance. So B cannot be the choice of 1. The C option is 1 only. 1 means 1 increase the braking force, and that cannot be the answer because increasing the braking force might decrease your stopping distance. But we are looking for that option in which we have a factor which will increase the stopping distance. So the number 3 is increase, the D option is 3 only. 3 only is increasing the speed of the car. Yes, when the speed of the car is more, the stopping distance is automatically increased. So D is the right choice. This wording is very tricky. You see, increasing the braking force, that decreases the stopping distance. Increasing the friction between the tires and the road, that decreases the stopping distance. Increasing the speed of the car, that will increase the stopping distance. And we were looking for that factor which will increase the stopping distance. So 3 only is that factor which will increase the stopping distance. So I think D is the choice. Question number 4, D is the right choice. For I said that this increasing the braking force, that is a little confusing sentence. The braking force, if in fact, it will decrease the stopping distance. Okay. So question number 4, D is the right choice. Question number 5 is coming up on the screen. So here we have question number 5 coming up on your screen. The diagram shows a satellite orbiting a planet at a steady speed. In which direction does the resultant force act on the satellite? Because the satellite is moving in a circular path. So the resultant force is always directed towards the center of that circular path. the option A, and also of that circular path. So I think that A is the right option. A looks the right option, sir. The direction of the resultant force, which we call the centripetal force, that should be always directed towards the, and that is always directed towards the center of the circle. So A is the right option. Question number 5, A is the right option. And let's move to the next question. That is question number 6. That is coming up on your screen. Okay. So we have question number 6 coming up on your screen. The gravitational field strength in space is smaller than on the Earth's surface. A rocket is used to launch a satellite from the Earth's surface into space. How are the mass and the weight of the satellite affected as the satellite moves away from the surface of the Earth and into space? So you see, when you will go into the space, the mass will be not affected. The mass do not depends upon the location, so the mass will remain unaffected. But the weight, because the weight depends upon the gravity. So as you move away from the Earth, the force of gravity which will be acting on that satellite will decrease. So the weight will decrease. Mass will be unaffected, but the weight will decrease. So I think you see both the mass and the weight are unaffected. That's wrong. The mass decreases and the weight decreases. Mass do not decreases. Mass remains the same. So B is also wrong. The mass increases and the weight is unaffected. That is wrong. Mass do not increase. Mass remains unaffected. So I think D is the option. The mass is unaffected and the weight decreases. So question number 6, I think D is the right option. So question number 6, D is the right option, sir. Okay, so on your screen, question number, next question coming up on your screen. Air is trapped in a cylinder by a piston. The piston is moved inwards so that the volume of the air reduces. So we are talking about gas, which is inside a cylinder. So the piston is coming into the cylinder. So here, if you count how much is the volume, just count 1, 2, 3, 4. So here the volume is 4, and how much is the volume here? The volume here is 1 and 2. So here the volume of the air is 4. Here the volume of the air is 2. So he says the density of the air in the syringe at the initial volume is 0.0012 grams per centimeter cube. So here the density of the air is 0.0012 grams per cubic centimeter. The question is, what is the density of the air in the syringe at the final volume? So what will be the density of the syringe in this volume? In this question, you know, in this question, the mass of the gas here and the mass of the gas here is same, because when you reduce the volume, the temperature will change, the volume will change, the pressure will change, but the mass of the gas is fixed. The mass of the gas will not change. So we are talking about the density. So the volume has reduced and the mass is still the same. So let me show you how I have done this. So here we go. So this is question number 7 coming up on your screen. You can see the question number 7 that is coming up on screen. Here I have shown that working. And for the option number 1, the density is equals to mass divided by volume. And you know the density is 0.0012 grams per cubic centimeter equals to the mass, suppose, is M, and the volume is V. The V value I counted from there. So the V value will be, the value of the V will be 4. So then M will be equals to 0.0012 multiplied 4, that will be 0.0048. So this much gram of the air is there. And so now in the second situation, the mass will be the same, but the volume has decreased to 2. So the density is equals to mass divided by volume, that will be 0.0048, the same mass, divided by volume in the second situation is 2. So 0.0048 divided by 2, and that will give you an answer of 0.0024. So I think C is the right answer for question number 7. C is the right answer. Hopefully you have understood. So let's move to the next question, and next question is showing up on your screen. So here we go. For this question, I think C was the answer. Question number 7, C was the right answer. Yeah. So let's move to the next question. The next question, which is coming up on your screen, is this. Some forces are applied at different distances from a pivot. Which diagram shows the force that produces the largest moment about the pivot? Okay, so here we have the A option, B option, C option, D option. The pivot is here, and the moment arm is 90 centimeter. The force applied is 50. It will be clockwise moment. We can calculate force multiplied moment arm. Here the moment arm is 2 meters. The force applied is 30 Newton. So just multiply them, and you will get the it is a clock. It's producing clockwise moment. You can calculate F multiplied D, the force multiplied the moment arm. Here the moment arm is 50 centimeter. The force applied is 80 Newton. And here the moment arm is 3 meter, and the force applied is 18 Newton. So you can calculate the moment arm. Let me show you my calculation. Here, the one thing which you have to keep in mind is the moment arm is 90 centimeter. Here the moment arm is 2 meter. So we can convert both these centimeters into meters, so the comparison will be fair. So the units must be consistent for the comparison. So let's go to the next question. Here the question is showing up. So here we have the next question, question number 8. I have done here, you can see 90 multiplied 50, and that will be 4,500 Newton centimeter. Here I converted the 2 meter into centimeters because in 1 meter there are 100 centimeters. So in the 2 meters, there will be 200 centimeters. So we will have 200 multiplied 30, and that gave you 6,000 Newton centimeter. Here we have 50 centimeter, 80 Newton, just multiply them, you will get 4,000 Newton centimeter. Here you have 3 meter, 3 meter means 300 centimeter. And the force applied is 18 Newton. So the moment will be equals to 300 multiply 18, that will be 5,400 Newton centimeter. So we were looking for that option in which the moment produces largest. So the largest moment produced here is 6,000 Newton centimeter. Hopefully you have understood this. This question is very easy. The only tricky part is that the moment arms in A and C, their units are centimeter, and the moment arms in B and D option, they are in meters. So they should be in the same unit. Both of them should be, all of them should be either in the centimeters, or all of them should be in meters. And then you can make a good comparison between them. So B is the right option, and I hope that you have understood this. So let's go to the next question. The next question coming up on your screen is question number 9. Here we have question number 9 is showing up. The diagram shows a children's wooden play tower. Which change to the tower makes it more stable? So if you want it to be more stable, its base should be larger, and the center of the mass should be lower. Okay, so let's see which change to the tower makes it more stable. So we are looking for more stable. Making the tower narrower will not make it more stable, because it will reduce the base. Making the tower taller, it will increase the height of the center of the mass. Lowering the center of the mass, yes, this is the answer, sir. And raising the center of the mass, no, it do not make it more stable. So C is the right answer. Question number 9. I think question number 9, C is the right option. Hopefully you have understood. So let's move to the next question. So the next question coming up on your screen. Where on the graph is the limit of proportionality? The limit of proportionality you see from here, from O to P point, the extension load graph is a straight line. It has a constant gradient. So here the load and the extension, they are directly proportional to each other. So, but after the point P, the graph has become a curve, which means that the extension and the load, they are no more directly proportional to each other. So this happened after the point P. So the point P is the limit of proportionality. So at P. So B is the right option at P, and the P is the point of is the limit of proportionality. Question number 10. So here we have question number 11 is showing up on your screen. The weight of 2 Newton is hung from a spring. The extension produced is 6 centimeters. So we hung a load of 2 Newton and the extension produced is 6 centimeter. The 2 Newton weight is removed and an 8 Newton weight is hung from the spring. The spring does not pass its limit of proportionality. What's the new extension of the spring? So very simple question. You know, the extension and the load, they are directly proportional to each other. Here, when the load is 2 Newton, the extension is 6 centimeter. And when the load is 2 Newton, the extension is 6 centimeter. When the load will be 8 Newton, what will be the extension? That is a very simple question. Let me show you. I have done this on a paper. So here we go. Okay, so on your screen, question number 11 is showing up, and you can see that I have solved it here. You can see here I have solved it. So load and extension, they are directly proportional to each other. I have used the process of proportionality, which you have studied in your O-levels mathematics. So load and extension, when the 2 Newton load, the extension is 6 centimeter. When 8 Newton load, the extension is X. I want to find out, because they both are direct load and extension, they are directly proportional to each other. So I wrote here 2 by 8 is equals to 6 by X, cross multiply. So X will be equals to 6 into 8 divided by 2. 6 multiply 8 is 48, divided by 2 is 24. So the extension will be 24. So I think B is the right option. So question number 11, B is the right option. Question number 11, B is the right option. Yes, B is the right option, sir. So let's go to the next question. Where is my Zoom? Okay, here we have. So it has gone here. Okay, so question number 12 is showing up on your screen now. An object is placed at a depth D below the surface of a liquid of density rho. On which expression does the pressure on the object depend? You know, the hydrostatic pressure, the pressure under the liquid is equals to, pressure is equals to rho GH. The pressure is equals to rho GH. Pressure is equals to rho GH, where rho means the density, that is a factor, okay? G is the gravitational field strength, that can be a constant, that is a constant, I mean, and so that can be, you cannot write, you can skip it. And D, H is the depth here is D. So on which expression does the pressure on the object depend? So the pressure is directly proportional to the product of the depth and the density. G is constant, depth and density. Okay, so I think B is the right option. Question number 12, B is the right option. You see, this is a tricky question on the pressure formula for the liquid, because the G, actually the formula is rho GH. Rho GH means density multiplied depth multiplied G, where G is a constant. So they have just skipped it. So the pressure is directly proportional to the product of depth and the density. So B is the right option. It's a little tricky question. Okay, so here we go. The diagram shows the dimensions of a box of mass M and weight W at rest on a table. Okay. What is the pressure on the table due to the box? The pressure will be weight divided by the weight of the box divided by the contact area of the box with the table. So the contact area of the box with the table is Y multiplies Z. Contact area of the block with the table is Y multiplies Z, length multiply width, and the weight is W. So the pressure of that box on the table will be weight, means W divided by YZ. So do we have this option? Yes, D is the option, sir. Question number 13, D looks the right option. Question number 13, D looks the right option. There we go. The next question coming up on your screen is question number 14. He says, which graph shows the relationship between the pressure and the volume of a fixed mass the mass is fixed and the temperature is constant? You know, when the mass is fixed and the temperature is constant, the pressure and the volume, they are inversely proportional to each other. And in your mathematics, you must have studied the chapter number 2 of the D2. There you might have learned that the two quantities, if their relationship is inversely proportional to each other, and then what happens that the graph is this B. Don't forget this diagram. This is the famous graph between the two quantities which have inversely proportional relation with each other. So the graph is always like this. So many people confuse inversely proportional with the diagram A, but diagram A is not the graph for inversely proportional. The graph for the inversely proportional is B. Don't forget it. Okay. Okay, so the next question coming up on your, so the B is the option, question number 14. Let me check. Question number 14, B is the right option, sir. So the next question coming up on your screen is question number 15. He says, the work done by a force F on a body is calculated by multiplying F by a quantity Q. What is Q? Okay, so the work done, you remember the formula of the work done? The work done is equals to the force applied multiply the distance moved by the body in the direction of the force. A famous formula for the work done. Work done is equals to the product of force and the distance moved by the body in the direction of the force. So the distance traveled in the direction of the force. Yes, that is that second quantity. A is the right option, sir. Question number 15, A is the 100% right answer without any doubt. So we are moving to the next question. That's next question is question number 16. A girl lifts an object of mass 1 kg from the floor and puts it on a ledge 2 meters above the floor. How much potential energy is gained by the object? The potential energy gained, the formula is very famous and very simple. The potential energy is equals to mgh. Potential energy is equals to mgh. I've done this on a paper. Let me show you my work. Okay, so here we go. So let me show you. So here we have that showing up on your screen. So the formula for the potential energy is mgh. The m is 1 kg, the g is 10 Newton per kg, and the h is 2 meters. H means the vertical height gained by the object. So when you multiply them, 1 multiply 10 multiply 2, that will be 20 joules. So the gain in the potential energy, will be 20 joules. So 20 joules. So D is the right option. Question 16, D, 20 joule is the right option, sir. Hopefully you have understood this, a very simple and a straightforward question. So the next question is coming up on your screen. Question number 17 is showing up on your screen. A copper rod is heated at one end. Which statement describes how heat transfer occurs in the copper? So when you heat one end of the copper rod, the heat is transferred from the hot end to the cold end by two processes. Both of them are called conduction, and one is by the vibration of the molecules. The molecules of the rod remain in their fixed positions, but they vibrate. So they transfer the energy from one molecule to the next, to the next by their vibrations. So they remain in their place. So but their amplitude of their vibration increases. So they make their neighbors vibrate vigorously, and the amplitude of their vibration increases. So by the vibration of the molecules, the energy is transferred from the hot end to the cold end. And the other important factor which makes the copper a very good conductor of heat is that the copper has free electrons in it. So the free electrons which are on the hot end, they absorb the energy and they can flow through the copper rod. So what they do, they absorb the energy at the hot end. The free electrons, they flow, they move to the colder end, and they collide with the molecules there and make them vibrate vigorously. So this way, this is called free electron diffusion. This process is called free electron diffusion. So by the free electron diffusion, the heat is transferred from the hot end to the cold end in the copper. So let's see, let's check what are the options. And the options are: the energetic copper molecules move from the cooler end to the hotter end. That is wrong. The molecules do not move. Their net movement is zero. Energetic copper molecules move from the hotter end to the cooler end. That is wrong. Energetic free electrons move from the cooler end to the hotter end. The free electrons actually move, but they do not move from the cooler end to the hotter end. They move from the hotter end to the cooler end. So the D is the right option. The energetic free electrons move from the hotter end to the cooler end. So I think question number 17, D is the right option. Question number 17, D is the right option, and I hope that you have also understood this. So question number 17, sir, D is the right option. Okay, so let's move to the next question. The next question is showing up on your screen. That is question number 18. He says, which heat transfer process do not require a medium? You know, the heat is transferred from one point to the other point by three processes: conduction and convection and radiation. Conduction and convection, they both require medium, and the radiation do not require any medium. So their question is, which heat transfer process do not require a medium? So radiation only. So I think question number 18, C is the right option, sir. C is the right option. Okay, so we have question number 19 showing up on your screen. It says the list shows 4 physical properties: mass, resistance, voltage, and volume. How many of these properties can be used to measure the temperature? You know, when the temperature changes, the resistance changes, so that can be used to measure the temperature. We make the thermometers based on the resistance of a metallic wire. Voltage can be produced, EMF can be produced by changes in the temperature. We make thermocouples, which are thermometers based on the voltage. So voltage can be used. Volume, the volume of the mercury, you know, when the temperature rises, the volume of the mercury increases, and that is used in the thermometers, the clinical thermometers and laboratory thermometers. So resistance, voltage, and volume are those characteristics which changes with the change in temperature, and they are used for making thermometers. The one thing which cannot be used to make a thermometer is the mass, because the mass is not affected by the temperature. So there are three things which are used for making thermometers. These are the 3 things. So how many of these properties can be used to measure temperature? 3. So out of these four, three can be used. So I think C is the right option. Question number 19, C is the right option, sir. And I hope that you have understood this concept. Here we go. The diagram shows a clinical thermometer. Which factor affect the sensitivity? So we are talking about sensitivity. Sensitivity of a thermometer, a constriction. The constriction has nothing to do with the sensitivity of the thermometer. The diameter of the bore, yes, that is the right answer. It's a famous concept. If you decrease the bore of the diameter of the bore in which the mercury travels, the thermometer will become sensitive. So B can be the answer. The length of the glass tube, no. On this, it does not depend. The sensitivity does not depend upon the length of that glass tube. The thickness of the glass tube, no. The sensitivity does not depend upon the thickness of the glass tube. So B looks the best option. The diameter of the bore is a factor which affects the sensitivity of the thermometer. So B is the answer, sir. So, and that is right answer. Okay, so now we are moving to question number 21. The question number 21 is showing up on your screen. Which statement about the thermal expansion of solids, liquids, and gases is correct? You know, when you heat up a solid, liquid, and gases, they all expand. But the gases will always show the largest expansion, then the liquids, and then the solids. So the largest expansion will be in the gases, and the liquids will have smaller expansion as compared to the gases, but larger than the solids. Solids will have the least expansion in them. So liquids do not expand, that is wrong. Liquid expand more than gas, that is wrong. Liquid expand more than solids, that is right, but less than gas, that is 100% right statement. Liquid expands the same amount as the solid, that is wrong. So C is the right option. A very easy question. Question number 21, C is the right option, sir. Okay, so question number 22 is showing up on your screen. He says, which row describes the shape of a liquid and the arrangement of its molecules? You know the shape of the liquid. Liquid always acquire the shape of the container in which you have put that liquid. So it takes the shape of the container. Arrangement of the molecules is not regular. The molecules in the liquid, they are not regularly arranged. So I think C is the right option. C takes the shape of the container and the arrangement of the molecules is not regular. So question number 22, sir, C is the right option. So the next question coming up on your screen, you can see that air in a sealed container of fixed volume is heated. So the volume cannot change. You see, the volume cannot change. The container is sealed, so the volume is fixed, so the volume cannot increase. The pressure of the air increases. So you have heated it, you have changed the temperature, the pressure will obviously increase, but the volume is constant. The volume cannot change. How do the molecules of the air cause this increase in the pressure? Because the volume cannot change. So the distance between the molecules cannot become larger. One thing, when you increase the temperature, the molecules will start moving faster. When they move faster, their collision frequency with the walls of the container will increase. So that's why the pressure will increase. Plus, because they are moving faster, so when they hit the container wall, they exert more force. So that's why the pressure will increase. But the molecules expand, the molecules never expand. Okay, the molecules move at the same speed and hit the container. The molecules do not have the same speed because the temperature of the liquid of the gas, has increased. So it means that the speed has also increased. The molecules move faster and hit the container more often. Yes, that is the right answer, sir. I think C is the best option given here. So because the temperature has increased, which means the average kinetic energy has increased, which means that the molecules of the gas are now moving faster. And you know, their collision frequency with the walls of the container has increased. So they will be colliding more often. They hit the container more often. The D option is the molecules move further apart and hit the container more often. The molecules cannot move further apart because the volume of the gas is constant. So C is the right option, sir. Question number 23, C is the right option. Here we have question number coming up on your screen is question number 24. It says a ray of red light in air enters a semicircular block. Which diagram shows the partial reflection and the refraction of the ray? So the light is entering into the block, it making 90-degree angle with the surface of the block. So there will be no deviation, there will be no deflection, and when it will hit the this second phase, here the reflection will take place, and the refraction will also take place. So which diagram is the correct one? For that purpose, what you have to do, you have to actually draw here normal. At this point where the light is emerging from this glass block, here you have to draw a normal. So in all these diagrams, I will draw a normal. Let me show you my work. And from there, you can see how this is done. So on your screen, question number 24 is showing up. So you can see that in all those B and C and D diagram, I have drawn the normal at the point where the light enters from the glass into the air. Here, the process of reflection and actually the total internal reflection has taken place, and also the refraction is taking place. So for the reflection, you see in the diagram A, here the reflection took place, the angle of incidence and angle of reflection, they should be equal to each other. So diagram A is wrong because here the angle of incidence is larger and angle of reflection is smaller. They should be equal to each other. So this is wrong. Here, this is also wrong because the angle of incidence and angle of reflection by the naked eye, by the inspection of the naked eye, you can tell that the angle of incidence and the angle of reflection, they are not equal to each other. So B is also wrong. In the C, you can see that the angle of incidence and angle of reflection, they looks to be equal to each other. That is right. Okay, but there we have problem. The light is entering from a dense medium into a rare medium. The light is supposed to bend away from the normal. When the light emerges from the glass into the air, the light bends away from the normal. But here you can see it has bended towards the normal. So C is wrong. Look at the diagram D. The angle of incidence, angle of reflection, they both are equal to each other. So for the reflection point of view, this diagram is correct. Now, for the refraction, the light when came into the air from the glass, the light was supposed to bend away from the normal, and it has bended away from the normal. So D is the right diagram. So D is the right option, sir. I hope that I'm able to make you understand the concept, how you rejected A, B, and C, and how come we know that D is the right option. So D is the right option, sir. So let's move to the next part, and the next part coming up on your screen is question number 23. Here we go. So we have question number 23 coming up on your screen. An object of height 1.5 centimeter is placed in front of a converging lens of focal length 2 centimeter. The arrangement is shown on the full scale ray diagram. So 1 centimeter here is equals to 1 centimeter. What is the linear magnification produced by the lens? The formula for the linear magnification is very simple. The formula, there are two formulas for the linear magnification. One is the height of the image divided by height of the object. One formula is linear magnification is height of the image divided by height of the object. The other formula is the distance of the image from the optical center divided by the distance of the object from the optical center. distance of the image from the optical center divided by the distance of the object from the optical center of the lens. So the height of that this you can see here, this is 1.5 centimeter. This is the object. The height of the image here is 3 centimeters. You can count if you have your hard copy with you, the hard copy of this paper. You can count, these are 15 small squares. So 5 small square equals to 1 centimeter. So 15 means 3 centimeter. So the height of the image is 3 centimeter. Height of the object is 1.5 centimeter. So let me show you. I have done this on a paper. So here we go. So question number 25 coming up on the screen. So the linear magnification is equals to the height of the image divided by height of the object. The height of the image is 3. The height of the object is 1.5. So the linear magnification will be 2. So the linear magnification will be 2. So the A is the right option. So question number 25, A is the right option, and I hope you have understood. Okay, so question number A is the right option, sir. Hopefully you have understood this. You can use the other formula also, that is the distance of the image. You can count here. This is the optical center. You can count up to this point, and that is the distance of the image, and the distance of the object will be from here to here. You can count the squares. If you have hard copy, then it's not a difficult thing. In which optical instrument is the distance between the object and the lens less than the focal length of the lens? A very famous instrument. When you use the magnifying glass, the magnifying glass is actually a convex lens, and when you put the object, the distance of the object from the lens is less than the focal length. The convex lens makes its convex, virtual image. The image is magnified, the image is erect, and we say this is magnifying glass. So so you put an object, in which optical instrument is the distance between the object and the lens less than the focal length of the lens? Magnifying glass. B option, a very straightforward and simple question. B is the right option, sir. Here we go. The sound from a ship is reflected by a cliff. An echo is heard by a sailor on the ship 4 seconds after the sound is made. The speed of the sound in air is 320 meters per second. How far from the cliff is the ship? So see, the sound is produced on the ship, it goes to the cliff and is reflected and comes back. Okay, so the sound of the echo is heard after 4 seconds. So if you know the speed of the sound, that is 320 meters per second, you just multiply it with the time. So 320 multiply 4, it will give you the distance traveled by the echo and the sound waves, and the distance between the ship and the cliff will be half of that distance. Let me show you my work here. Okay, so hopefully you can see this. So the distance traveled by the sound wave is S multiplied T. The S is 320 speed, that is 320 meter per second, and the time taken is 4. So just multiply them, you get 1,280 meter. So that is the distance the sound covered in going to the cliff and then coming back. So the sound from the ship went to the cliff, got reflected from there and came back, and you heard the echo. So the distance between the ship and the cliff will be half of this distance. So just 1280 divided by 2, 640. So the distance between the ship and the cliff is 640 meters. So B is the right option. B is the right option, sir. B is the right option. B. And I hope that you have understood that how this question is done. Students are asked for the uses of ultrasound. Three suggested uses of ultrasound are cleaning jewelry. Yes, the ultrasound is used for the cleaning jewelry. Tanning on the sunbed. No, that is wrong. The tanning on the sunbed is the use of ultraviolet, not ultrasound. It is the use of ultraviolet rays. Okay. Obtaining an image of an unborn baby, yes, we call it ultrasound, yes, in famous name ultrasound. So P and R, they are the uses of the ultrasound. Which suggestions are correct? P and R, P and R, P and R, P. Three suggested uses of ultrasound. He says which suggestions are correct? P and Q only, that is wrong. P and R only, yes, this is the option. So I think B is the right option, sir. Question number 29, B is the right option. Question number 29, B is the right option, sir. Okay, so we are moving to the next question. The next question coming up on your screen is question number 30. End X of a metal rod attracts the north pole of a compass needle. Which statement about the rod is correct? It is made of copper that is not initially magnetized. You see, the north pole is not attracted towards, or compass needle is basically a magnet. So the compass needle cannot be attracted to a copper which is not magnetized. So it cannot be attracted to the copper. So it cannot be the option. It is made of copper with the south pole at the X. You see, if it is made of copper and it has a south pole at X, maybe it's made of copper, and normally what happens, the copper cannot be magnetized, but he says that has a south pole at the X, because the north of the compass needle will point towards the south. Yes, that is right. So B can be, or maybe, but the problem is that the copper do not magnetize. So B has a doubt in it. Okay. So it is made of steel that is not initially magnetized. The compass needle is not attracted to a steel which is not magnetized. It is made of steel with the north pole at the X. It is made of steel with the north pole at X. It is made of steel with the north pole at. If it has north pole at X, then the compass needle will not be attracted with it. Okay, because the tip of the compass needle is north pole itself, so it cannot be attracted. So it's a very tricky question. If you look at carefully, let's pay more attention. It is made of copper that is not initially magnetized. That is totally wrong. So it's out of question. It is made of copper with the south pole at X. The copper cannot be magnetized. The problem with the copper rod is the copper rod cannot be a magnet. So that is also kind of rejected. It is made of steel that is not initially magnetized. So because the compass needle is magnet and steel is a magnetic material, so that magnet should be attracted to that steel. It can be attracted to that because the steel is a magnetic material. So the attraction between the tip, the magnetic needle, compass needle, is understandable. Yeah, C can be the answer. It is made of steel with the north at the X. That is totally wrong. If at X we have the north, the north of the compass needle will be repelled. It should not be attracted. So I think C is the right option. It is made of steel that is not initially magnetized. C is the right option. Very tricky question. Here we go. Question number 31. A positively charged rod is held. A positively charged rod is held close to an insulated metal sphere. The sphere is earthed as shown. The earth connection is removed and then the rod is removed. Which diagram shows the charges on the sphere after the rod is removed? You see, here you have bought a positively charged rod near this metal sphere. It is insulated. So obviously all the electrons will accumulate here. Here you will have negative charge and here you will have positive charge. Now you have connected earth with it. So from the ground, the electrons will come and they will neutralize this positive here. So from the ground, the electrons came here and neutralized this negative positive here. But these electrons which were here due to this rod are still there. So when you will break this earth, what will happen? You will realize, and then you remove this rod, you will realize that it has now got extra electrons from the ground. So this rod will become negative. I hope you have understood. So I think C is the option, but let me show you. I have done this on a diagram also, so you can understand it more easily. Let me show you. So you can see here that when you bring the positive rod near this metal sphere, this end will have all the electrons will accumulate here, free electrons, I mean. So here you will have negative charge, here you will have positive charge, and you have connected with this with the earth. So due to this positive charge, these negatives cannot go anywhere because of this rod. So from the ground, the electrons will come and they will neutralize this positive. So this positive will be neutralized. It means that from the ground, the electrons have came onto the sphere. When you break this earth, so the electrons cannot go back, and then you remove this, then you realize that it has got extra electrons from the ground. So this rod will become as a whole negative. So C is the right option. Question number 31. I think, sir, C is the right option. Question number 31, C is the right option. Yeah, question number 31, C is the right option, sir. So let's go. Question number 31. So you have the C is the right option. So where is that? Here we go. Question number 32 is showing up. The diagram shows a circuit. The diagram shows a circuit. Okay, so here we have EMF. This battery has EMF 12 volt. There are two resistors, 5000 ohm, 5000 ohm. They both are connected parallel to each other. So here we have an ammeter. The ammeter has 4 different ranges. Which range setting gives a reading near the midpoint of the range? Okay. So first of all, let me find out what is the total resistance, the equivalent resistance or combined resistance of these two. Because these two are connected in parallel to each other. So 1 by R equivalent is equals to 1 by R1 plus 1 by R2. I will use that formula. I will find the total resistance of this circuit. And then I will find the current coming out of the battery. Current I is equals to EMF divided by the total resistance. So let me show you my work. I've done this on a paper, and from there you can. So here we go. Oops, sorry. So the equivalent resistance I can find by the formula 1 by R is equals to 1 by 5 plus 1 by 5. So 1 by R will be equals to 2 by 5 cross multiplier. So R will be equals to 2.5 kilo ohm, which means 2500 ohm. So the total resistance of this circuit is 2500 ohm. And now the current coming from the battery is equals to the EMF divided by the resistance. So 12 volt divided by 2500 ohm. So the answer is 0.0048 ampere. So, this is the reading in the ampere. So if you want to convert this reading into milliamperes, you have to multiply it by 1000, because in 1 ampere there are 1000 milliampere. So when I multiplied with 1000, I got 4.8 milliamperes. So the current coming from the battery is 4.8 milliampere. So the reading shown here is 4.8 milliampere. So which of these will have which of the range? This should be the half of the range. The question is, this should be the half of the range. So I think this has a 0 to 10 milliampere. So half of this will be 5. So yeah, this B is the correct answer. B is the right option, sir. Question number 32. B, hopefully you understand this. B is the right option. So B is the right option, sir. In which example is the current 1 ampere? In which example is the current 1 ampere? A charge of 0.1 coulomb passes through a resistor in 100 milliseconds. A 10-volt lamp with input power of 0.10 watt. A resistor of resistance 0.5 ohm with a potential difference of 2 volt across it. Two resistors with a current of 0.50 ampere connected in series. Okay, so D cannot be the option because the two resistors which are connected in the series, they have the same amount of current flowing through them. So the current flowing through them is 0.50 ampere. So the D cannot be the answer. The D is rejected directly. Okay, so let's check my answers. I've done this on a paper, so let me show you my answer. Here we go. So for the first option, the charge is given and the time is given. So the charge is 0.10 coulomb. The time is 100 milliseconds, but we do not put the time in milliseconds here. We convert milliseconds into seconds. To convert the milliseconds into seconds, you have to divide it with 1000. So 100 millisecond. So we have 100 divided by 1000 to give you 0.1 seconds. So for the A option, the current will be 1 ampere. So A is the right option actually. Okay. B, a 10-volt lamp with the input power of 0.10 watts. So I know the power here and I know the voltage. I want to calculate the current. So P is equals to IV. I will be equals to P divided by V. 0.1 watt divided by 10 volt. The answer will be 0.01 ampere. So B cannot be the answer. A is actually the right answer. A resistor of resistance 0.50 ohm with the potential difference of 2 volt across it. You know, V is equals to IR. V equals to IR. I is equals to V by R. So 2 divided by 0.5, that is 4 ampere. So C cannot be the answer. D, I already told you, it cannot be the answer. So A is the right option. Question number 33, A is the right option, sir. Question number 32, A is the right option. I hope you have understood that how we have done this. Okay, here we go. Question number 34. Which graph shows the relationship between current and voltage for a filament lamp? You know, here the graphs are shown and the current is on the y-axis, the voltage is on the x-axis. The slope will be current divided by voltage. The slope here of these graphs is equals to the reciprocal of the resistance. Slope here is equals to 1 by R. And you know, as you increase the voltage across a filament lamp, its resistance increases. So if the resistance increases, it means the slope should decrease gradually. So in which diagram the slope is gradually decreasing? That is A answer. Let me show you. I've done this on a paper also. Let me show you that. Okay. So the here in these graphs, the slope is equals to the y divided by x, I by v. And you know the I by v is equals to 1 by R. So the slope is equals to the reciprocal of the resistance. And we know that as you increase the voltage, the resistance of the filament lamp also increases. So the slope should gradually decrease because the slope is opposite to the resistance here. So A is the right choice. I hope you have understood a famous diagram. That diagrams are also present in your textbook. Question number 35 is coming up on your screen. 100-watt lamp is switched on for 5 hours each day for 3 weeks. The cost of 1 unit of electricity is $0.24. How much does it cost to run the lamp for this time? So if you want to if you want to find out the cost of running a lamp or any other electric appliance, the power should be in kilowatts, not in watts. The time should be in hours, and you multiply that thing with the cost of 1 unit of electricity. So let me show you. I've done this on a paper. Okay, so here we go. Okay, so on your screen, it's coming up. You can see there, and sorry. Okay, so here we have. So the cost will be power multiply the total time multiply the price of 1 unit. And the power should be in the kilowatts. For that purpose, I have divided the watt thing into. I have divided it with the 1,000, and 5 hours each day, and 3 weeks, and in each week we have 7 days. And the cost of the 1 unit of electricity is 0.24. So just do this calculation on your calculator. Your answer will be 2.52. So the bill will be $2.52. Hopefully you have understood. In this formula, the power must be in the kilowatts. Okay. So C is the right option, sir. Question number 35, C is the right option. Question number 35, C is the right option. Okay, so let's go to the next part, and the next part is coming up on your screen. So let me, where is my camera? Okay, so here we go. A 3-pin main plug contains a fuse, a device which with double insulation has a cable connected to the plug. So the double insulation do not require the earth wire. Actually, you know that it requires neutral wire, it requires live wire, but it do not require the earth wire because it has double insulation. It means it has double layer of the plastic around it. So there is no chances that the live will come in contact with the body, and the body will become live. So there are no chance because the body is made of plastic. So there is no need for the earth wire. So which part of the plug is not connected to the cable? The earth wire, the earth pin actually. So A is the right choice. It has fuse, it has live pin, it has neutral pin, but it do not require earth pin. Question number showing up on your screen is 37. I have to reduce its size, because the question is huge. Okay, so try to understand this question. The trolley carrying a strong magnet rolls down a ramp at constant speed. It passes through a coil as shown. So we have a magnet on that trolley. So, and we have a coil on that ramp. So when the trolley will pass through that coil, a magnet will pass through that coil. So EMF will be induced in that coil. Okay, so understand. Electricity will be produced, or you use the word induced in that coil. An electromotive force EMF is induced in the coil. A graph of the EMF against time is plotted. The experiment is repeated with different coils and with a steeper ramp. So when you make the ramp steeper, the trolley will move faster. When the trolley will move faster, the EMF produced will have, its time period will reduce. One thing which will happen, the time period of that wave of the EMF which is produced, the graph will have the less time period. and its amplitude of the voltage will also increase, obviously. The trolley moves at a greater constant speed on the steeper ramp. Which graph is produced using the coil with the least number of turns and the steepest ramp? All graphs are drawn to the same scale. So you see, because we are going to use a coil who has the least number of turns, the EMF induced depends upon the number of turns of the coil. If the number of the turns on the coil will be least, then the EMF or the amplitude of that wave should reduce, should be the least. And because the trolley is moving faster, because the magnet is moving faster through that coil, so the time period should decrease. So the time period should be least and the amplitude should be least. So where do we have that option? Where do we have the least time? Where do we have the least time and the least amplitude? Not here, not here. They have the greatest time. These two have the least time and the least amplitude is here. So C is the option. A very, very tricky question. C is the right option, sir. Question number 37. Hopefully you have understood. Very tricky question, a brand new question in 2021. Question 38 is coming up on your screen. A student uses a transformer to light a filament lamp using a 230 volt AC supply. So the voltage in the primary is 230. The lamp has a maximum voltage rating of 6 volt. The lamp can only bear 6 volt. The turns on the primary, they are 300 turns. The turns on the secondary, there are 20 turns. So it's a step down transformer basically. What happens with the circuit when the circuit is switched on? Okay, so we have to calculate how much voltage is produced here. This lamp can only be a 6 volt. So let me show you. So here we go. Okay, so here we go. You can see that I am using this equation. The voltage in the secondary divided by the voltage in the primary is equal to the number of turns in the secondary divided by number of turns in the primary. The voltage in the secondary is question and the voltage in the primary is 230 volt. The number of turns in the secondary, there are 20 and the number of turns in the primary is 300. So you will have Vs is equals to 20 multiplied 230 divided by 300. So the answer will be 15.33. So the voltage produced in the secondary is 15.33 volt. And that voltage will be provided to that lamp. But that lamp was only able to bear how much? 6 volt. And you have given it 15.33 volt. So the lamp will switch on with a very bright light and then it will fuse. Okay, so this is what will happen. The lamp lights up brightly and then goes out. D is the right option. The rest of the options, the lamp does not light at all. That's wrong. The lamp lights at normal brightness. No, the voltage you produced to give it is very high as compared to this normal voltage. The lamp lights dimly. No, that is not the case. It will light up brightly. And the D is the light. The lamp lights up brightly and then goes out. Yes, because the lamp can bear only 6 volt, but you have provided it with 15 volt. So what will happen? The lamp will fuse, but when it will light up, it will be very bright and then it will fuse. So D is the option. Question number 38. D is the right option, sir. Okay, so question number 38, the D is the right option. So question number 39 is coming up on your screen. He says, what does an alpha particle consist of? Alpha particle is actually the nucleus of helium. The alpha particle is like the nucleus of helium. Okay, so the alpha particle is like the nucleus of helium. It has 2 protons and 2 neutrons in it. Alpha particle has 2 protons and 2 neutrons in it. There are no electrons. It's like nucleus of helium. So 2 electrons, wrong. 2 protons and 2 neutrons only. Yes, B is the right option. And C, 2 protons and 4 neutrons only. That's wrong. And 2 protons, 2 electrons. Electron thing is wrong. So B is the right option, sir, where you say 2 protons and 2 neutrons only. So for question number 39, I think B is the right option. Question number 39, B is the right option, sir. Okay, so we go to the next question. The next question is question number 40. And he says the count rate from a radioactive source falls from 4,000 counts per minute to 5,500 counts per minute in 72 minutes. What is the half-life of the source? Okay, so let me show you how we have done this. I've done this on a paper. Okay. So here you see this is my style of doing these questions. So initially the count rate was 4,000. So when one half-life will pass, the count rate will it will become 2,000. Another half-life will pass and the count rate will become 1,000. And another half-life will pass and the count rate will become 500. So count how many half-lives? 1, 2, 3. Totally 72 minutes have passed. So it means 3 half-lives equals to 72 minutes. So one half-life will be 72 divided by 3. So 24 minutes. So D is the right answer. D is the right answer. So my dear students, today in this session, we have done May-June 2021 1-2 paper. The subject we are studying is Physics 5054. And I hope that this session has been helpful to you. If this session is helpful to you, please don't forget to subscribe to my YouTube channel. And when you watch this video and this improves your concept, I will request you to share the link of this video into your Facebook, onto your Instagram accounts, because this will help me to promote my channel. And I will continue this work, make me able to do this work. So thank you very much. And it was a pleasure teaching you all, teaching you the concepts of the physics. I hope that I am a little help to you. So thank you very much and have a good day and God bless you all.